So hello everyone, this is day 11 of writing 15 smart contracts in 15 days. But from today, we will be changing the format a little bit because till day 10 we have written just simple smart contracts, but I think I haven't made something impactful, right? Like a full-fledged decentralized application. So in previous video which I made that was about DEX, right? I explained you what is DEX. And so it will be a good idea to make our own decentralized exchange, right? So for that, what will we be needed? Uh, First, we will be needed two tokens that are token X and token Y, right? So yeah, we will be creating a liquidity pool for token X and token Y from where the users can actually swap token X for token Y and token Y for token X, right? So, in order to make our own decentralized exchange, what smart contracts do we need? Initially, I have made a simple plan for what will we be needed. So, for in smart contracts, we will be needed a pair of tokens, right? And the tokens are token X and token Y, right? Initially, this token X and token Y will be stored in a owner's wallet, right? Then what we need is a faucet smart contract, right? Now, what does this term faucet smart contract means? I will quickly show you this. Going on a faucet, we have a Google faucet as well, from where you can claim your Sepolia Testnet ETH. I do claim that every day. So from here, actually, if you select this Ethereum Sepolia Test ETH, you can actually get 0.05 ETH every day. You just have to paste your wallet address over here and just click this receive button. You will get Sepolia ETH into your wallet, right? So we will be able to build something similar to this. Like I will be holding a token Y and token X into my wallet, right? Over here, and I will be having a smart contract called Faucet Smart Contract, right? Which will then in that faucet smart contract, which is over here, I will be transferring some amount of tokens from my wallet address to the address of this contract, right? So this faucet smart contract will be storing some amount of token X and token Y, right? And now let's say if you want to claim token X and token Y, so you can go to the front end. We will also be creating a front end for this, the faucet front end, right? I have mentioned it over here. Yes, the token faucet front end. You can actually go there and connect your wallet simply and paste your wallet address over there, and you can actually request for token X and token Y, and you will receive your token X and token Y in your wallet address, right? So yeah, this was about the factory. This was about the faucet smart contract, right? Then what we will be having is a liquidity smart pool, liquidity smart contract. Mm, One, two, three, start. Then what we will be having is a liquidity pool smart contract, right? So what does this smart contract do? This smart contract will actually create a pool for token X and token Y with a specific number of ratio. Let's say we'll be keeping it 50, we'll be keeping it, yeah, 50-50, right? Because we will be storing uh, same amount of token X and token Y into our pool, right? So let's say this will be our pool, right? So there will be equal amount of token, uh, token X right? And equal amount of token Y, right? So yeah, that will be our liquidity pool smart contract, right? And if we need something else, I'll be adding it up over here, right? But as of now, just to get an overview, this is pretty much it for the smart contracts. Then in backend, we will be needed will need something to fetch all the created pools, right? And then what we will be needed is to get the positions of the users into the pool, right? So the users should actually get the information about how much have they invested into the pool, right? And a simple request for calculating the profit and loss of the user, right? And then in the front end, what we will be having is a functionality to connect a wallet, right? Then we will be having this faucet smart contracts front end, a front end from where actually the users can claim token X and token Y, right? Then we will be having a page, or let's say, yeah, we will be having a page to add or remove the liquidity, right? Then we can give a functionality to create a pool as well. And the most important thing, from a page from where the user can actually swap the tokens from the pool, right? So this is pretty much it, right? For creating our own DEX, right? So today, what we will be doing today, we will be creating token X and token Y, and we'll be writing a faucet smart contract for it and deploying it as well to Sepolia Testnet, right? So yeah, let's just code it up. So let's just let me open up my terminal. So I'll open up my terminal. This was open here. Okay, so I'll navigate to desktop. I'll make a directory called uh, DEX, right? And enter. Then I'll navigate to text, text, right? And then uh, this will open up this folder into my code editor. Yeah, so I have opened up my project into our code editor. Now what I need is to initialize this project and set up Hardhat onto this project. Now I will do npm init. Oh, I need to plug in my charger. Okay. Package name is text. Yes, yes. Okay. Okay, 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 okay. Yes. So I got my package.json over here. Now let's go to the harder documentation and then setting up a project. npm init. We did that. npm install. This will take some time, and then let's just copy the another command, that is npx hardhat init. Let's call it like this. Paste it over here. Set up a JavaScript project for me. The root directory is DEX. Yes, and I git ignore as well. And it's installing for me, right? So our Hardhat project is ready. And now what we are having over here, the contracts folder. I delete this up, right? Why is it taking some time? Create a file over here called token a dot solidity, right? Now what we yeah, need is to build ERC20 token. So yeah, for that, let's go to over here, which is Open Zeppelin Wizard. From here, what we can do is just copy the template code from here. So here I will name it as token A, and not token A, token X, EKX, right? And the payment, I'll payment 1,000 tokens, right? And yeah, this is pretty much it. I'll copy it, go to this, paste it over here, right? So I got the code for my token, the X token, right? Now what I need is to actually npmi this OpenZeppelin contracts. Yeah, so this got initialized, right? And yeah, this is code for TokenX. And similarly, we'll be creating a contract, simple contract for token Y as well. Why did I name it as token A? Mm, we name it as token X. This is token Y, dot solidity, and over here I'll just paste this. We right, and I'll change this name token Y, and PKY will be the symbol, right? And we actually don't need this in the constructor, right? And we need the one who deploys the smart contract will be the owner of this token X and token Y. So it will be message.sender, right? Similar for token X as well. Here, I will be doing message.sender, right? Now, as we have this token X and token Y, TokenX and TokenY smart contract ready, right? Let's just deploy this using ignition script, right? So I'll delete this, okay? And we'll create an ignition script for deploying our token, right? So deploy.js. Here, what I need is cons build module equals to require. I should get suggestion after I, yeah, it's foundation. I need ignition ignition slash module. Right? Okay. And then what I need is export module dot exports. Then build a module, right? We name it as token module. Yeah, right. Token module, token module, comma, then the arrow function. Okay. Now over here we need our token x equals to m dot contract and dot contract token x, right? And cons token y equals to m dot contract token y, right? And what will it return? It will return token x, comma, token y. What is this saying? Oh, we need to destructure it. I bet this would work. That was TokenX. Yeah. So yeah, that should work, I think. Okay. Now what I need is to deploy this onto Sepolia Testnet, right? So what I need is a URL, RPC URL, and we will be needing the private key, right? So let's just go to this right here, config, right? And I'll just copy this network thing, this one, I guess, yeah. Right. Then just paste it over here. What is it saying? Let's just fix it in chat. Okay. So this has given me an endpoint. Now just I have to paste my key over here and I have to paste the private key over here. So for that, I need PNV also. So np I dot env. We create a PNV file for that just to store my private key and the RPC URLs. Right. So yeah, I will make it in my root directory. env over here, private key equals to my private key and Infura URL. Right. So yeah, I'll paste my uh, I'll paste my URL over here and my private key over here. So just give me a second. So I have stored my private key over here and my Infura URL over here, right, from my .en. Right. So let's now deploy our ignition script. So I will write npx hardhat ignition deploy /ignition modules and deploy.js network is Sepolia. Okay, and just hit enter. Yeah, so okay, I was getting some errors in my ignition script, so I just resolved that and I have deployed TokenX and TokenY onto Sepolia Testnet, right, using my wallet address. So we can actually check this from Etherscan. So this is my wallet address, and these are our deployed contract. So yeah, this is the contract for TokenX deployed using this wallet address, and this is the contract for token Y deployed with this token address. Right? So for today, let's just keep it simple to this point where we have created two tokens, that is token X and token Y, and we have actually deployed it to Sepolia testnet using our ignition script, right? So yeah, from tomorrow, I will be continuing this project only, and tomorrow we'll write a smart contract to actually build a faucet for these two tokens from where the another users can actually claim token X and token Y. So, okay, thank you. See you guys tomorrow.